You will need a soldering iron, screwdrivers, solder, solder wick, needle nose pliers, a wet cloth or sponge, diagonal cutter, and a dental pick. A soldering station with a soldering iron mount is desirable. Plug in your soldering iron, and then you always set it, and you always put something underneath it so that it won't flop over and burn. Because it takes a while for it to heat up. Sometimes I tighten this little screw. Now this is an inexpensive soldering iron, just so that shows everybody can do it. Solder. I'll put a little cloth down here underneath the iron that's wet. Of course, most people would have like a little fancy holder, but I'm just showing you can do it with cheap. See, this rag's wet, so I can do a little cleaning. I'll sniff it to see if it's hot. You gotta be careful.
Burn your nose.
You want to go, when it gets hot enough, it'll start taking this solder. It's not hot enough. I give it a little time. You always got to keep your attention on where this is. Now what I did earlier when you weren't here, I have a meter that's different from this one, but I just testing these.
Make sure they're all dead.
Well, there's actually what they call a AC ohm meter, and I can, if I didn't know what was wrong with this board from looking and getting people's information from before, I'd go on all those electrolytic capacitors one by one, and I'd see the ones that didn't have conduction on the AC ohm meter.
Yeah.
And that would be a bad capacitor.
Be a bad capacitor.
And I've gone on boards like this before, and I've just, you know, I didn't know which one was bad, but it's a switch in power supply, so I knew it was probably a capacitor. Check all the electrolytics, replace all the bad ones, mark them with a marks a lot, pull them out, and then and put in new ones, and it usually fixes it 99% of the time. And if I did the job right, if I didn't make a bad solder joint or something. Let's see if this is going to melt solder now. Look, it's melting.
Oh, yeah.
It's melting. Okay, that's got fresh solder on it, so it'll work. And now, we want to clean it. See, look how clean and shiny that is. See? It's got to be clean and shiny.
Did you already change them?
No. We're at the beginning of changing them. That's the process.
Oh.
How's it look?
Yeah, it looks fine.
This is solder wick. This is what you use to remove solder braid. And so we got them marked here and here and here and here. Now what I'm going to do is I'm going to add a little bit of solder to these connections just so it'll flow easily when I go to remove it. Don't have to do that, but see that one? And that one, and this one. You got to be careful because you can actually burn the trace off the board, and you have to fix it then. Or you can make a solder point that won't work. Still not quite hot enough. It's needing to give me some more heat. Sometimes it's as simple as this isn't screwed in tight enough here. And now it's got a better connection. You see it starts heating up a lot more after I do that. You got to get it pretty hot to pull the solder out. Now what I'm putting this extra solder on here for is so that when I go to wick it up, it'll readily come out. You don't have to do that, but these looked a little dry. Maybe had some rosin on top of it or something. Okay, then you get your solder wick and you hold it down on top like this. Some people use solder suckers. And you'll see the solder will start to flow and fill up the wick like that. See, and it made a...
Yep.
I don't know if that's good enough. I'd have to... I don't want to do that one.
No, you don't.
That's not it. And you have to work with these a lot to get that solder out of there.
So where do you buy the wick?
Oh, any Radio Shack will sell them.
Oh, okay.
And I may have to wick it again after I straighten up the leads. You have to work with this. Right now I'm just getting all the solder off. People say, well, you're getting the solder off you just put on, but that makes it flow a lot better. You're seeing it's making a slide hole.
Mm-hmm.
Interesting. I'll watch the video later.
These really aren't designed to be unsoldered. That's the hassle with it.
It's designed to replace a whole board.
What?
It's designed to replace a whole board.
Lots of times that's all they did was, if I damage this, I have lots of levels I can go to repair it,
Yeah.
but I'm trying not to damage it at all, so I don't have to repair it. And it's a challenge because, it really isn't designed to be unsoldered. We get closer. Okay. We're trying to loosen these up a little bit. Lots of people are screaming, if you had a better soldering iron, this would work. One thing I often do is come underneath and pry on it, like pull it and pulling to one side, see?
One side.
And then I'm loosening it by doing that. And then here, I'm loosening this one without pulling so hard I'd break the capacitor. I pulled that out, see?
Mm-hmm.
See, it popped out from the bottom. This in here, same thing. Pulling toward one side. And then it comes out. I'm pulling that, and that came out, see? Now we have to go in here. And these two are a little harder to get to. Like that, and then let that, well, I have to let the solder melt. That came out, and then there's this one here. That came out, and this in here. That came out. See, so we got all four of them out. Now the next step is to clean up the holes where you can put a new one through. So once that's out, you put that down on top of the hole, and then suck all the solder out of the hole. The hole is plated all the way through, so it'll suck the solder through the top and the bottom. Do the same thing over here. how that came out. Right here. Suck that all out where it's clean. See how that's clean? Got a hole all the way through. We got a little bit of dirt here. We have to clean that. Lots of people go through all this work and put the capacitor in backwards and blow out the board. See how that's a nice hole there? They got a hole? Yeah. Okay. Now y'all know how to do that. I'd let you do one of them. I'll come in here and make sure that I can go through this hole here. See? That went right in. That went right in. This went right in there. This went right in. This went right in here. No, this one's not good. This one's good. This one's good. And this one isn't. These two need to be touched up again. Another thing that's neat is on the writing on this, you can see they have a plus, and so it tells you the polarity of these. It's already written on the board if you really forget. So now we got to come and get these two that I couldn't get the tester to let that go through. A little probe in there. Now that looks good. Okay. And see, I want to put this, keep that from overheating. Okay, now we'll go here again. Make sure we can get there, and there, and here, and here, here, and there, and there, and there. Okay, and I'm going to take a little cloth. It's got not a lot of cleaning on it, but some, and clean off this stuff I got on here from the rosin and everything. So that's a clean surface. As clean as you can get. We got a lot of spare rosin here. You want that to dry out good too. Okay. Next step is get your new capacitors. You can do this now. They have a fancy opener on this somehow.
Don't look like it.
Yeah.
Or it goes down the side, maybe.
Yeah. There's it. I missed the obvious.
Down the side. Down the side.
Okay. Replacing 4. I think that's all we need to replace. I didn't see any more obvious ones. Okay, so we're going to come over here. That's all good there. And look here, it shows you negative, negative. Not some don't do that. They don't tell you what negative, negative. So it shows us here, and it matches the marks we put in. So I'm putting in a bigger capacitor. This is the ones we took out were 1,000 microfarads, 10 volts. I'm putting in 1,000 microfarads, 35 volts, because that way that means they won't be replaced again in the lifetime of the unit. See, negative side goes toward that. So put that there. And I bend it a little bit so they don't pop back out. And then the same thing, you got to watch this polarity. You get one of these in backwards, it blows out everything. Just so you know, these are capacitors. These are electrolytic capacitors. These little tall ones like this. That's an inductor. Those are diodes. That's resistors. This is a heat sink for transistors. Transformers. These are transformers. These are relays right here. Relays, capacitors. That little light bulb shows you if you have AC voltage. Bigger capacitors, transformer, high voltage transformer. Okay, put this in. Polarity's right. You always got to have your polarity right. Same thing here. Okay, we'll turn it over. Can you see it okay?
Yeah, oh
Is it a close-up? Now these right here, we want to make sure these are all 1,000 microfarads, see? That they're 1,000 microfarad at 10. We took out 1,000 microfarad. That's 1,000 microfarad at 10. And we replaced them with 1,000 microfarads at 35. And the 35 is the voltage rating. It tells what's the maximum voltage it takes where it pops. So I'm taking it further away from the point where it's going to pop. Solder it in. Solder should flow like a water or liquid. If it doesn't flow like a liquid, it's not making a connection. See this little bulbed up, so I'm going to let it flow a little more. Can you see how that works like a magnifying glass? How does that look? Because I can't see all that clearly because the smoke is coming my direction. Okay. See, that's not wanting to go up, so I'm going to take this and make sure that doesn't fall. And I'm going to examine this with to make sure that it's all connected good. See, that's solid, that's solid, that's solid, that's solid. You come in and cut. So you want to make sure these are short, because if they're too long, they'll short out against the stuff below it when you set that back in there. Okay, we're done with the soldering iron part. So I'm going to unplug it, but I'm going to let it set, cool off. Just measure it again to make sure. This shows me I have continuity to the rest of the board. Then the solder joints are good. Because if this was a bad solder joint, it wouldn't have conductivity.
Okay.
So I got all that done. I'm gonna flip the board over. And I'm gonna just like make these where they're at right level. And I'll make sure that all the polarities are right. How about that?